Chapter 18, Solving Proportions. Before we get started with a proportion, we need to understand what a ratio is and how we can express ratios. Simple definition, we're just relating two quantities relative to each other, and usually that's done through a fraction. Okay, and we're relating, in this case, a quantity A to a quantity B. Well, we usually see those written as fractions, but there's also other ways to write them, such as A to B or A colon B. Okay, but notice if it's written as A to B or A colon B, then A would go on top and B would go on the bottom if the ratio was expressed as a fraction. So example 1, we're given a number of boys, 8, and a number of girls, 9, in a class, and there's several different ways we could write a ratio between boys and girls. And so A wants us to write the ratio of all students in the class to girls. Okay, so all students would be boys plus girls, which if there's 8 boys and 9 girls, then that would mean that there's a total of 17 people in the class. So for A, all students, 2 girls, we would write 17 to 9, or we could write 17 colon 9, or in the form of a fraction, we could write 17 divided by 9. Okay, B, what is the ratio of boys to all students in the class? Okay, we could write boys, which is 8 with a colon, and once again we have all students, and this time it will come second in the ratio. Or likewise we could write 8 to 17, or 8 divided by 17. Okay, what about C? What is the ratio of boys to girls? So we have boys to girls, and that is the equivalent of 8 to 9, or 8 colon 9, or 8 over 9. Okay, so this is C. 8 to 9, 8 colon 9, or 8 divided by 9. And finally, what is the ratio of girls to boys? Well, we would simply flip the ratio from C. So if I make some room here for D, girls to boys would be equivalent to 9 to 8, or 9 colon 8, and then finally as a fraction, 9 over 8. Okay, so this is what a ratio is. You can think of it as a single fraction. So now we talk about what a proportion is. Well, A proportion is just a statement of equality between two ratios. So we have two fractions that are set equal to each other, and as we saw earlier in the semester, fractions can be written based on different numbers. For instance, 8 divided by 2 is equivalent to 4 over 1, because both 8 and 2 are divisible by 2. Likewise, we could write this as, let's see, we could pick any number and multiply the numerator and denominator and get an equivalent fraction. 4 times 5 is 20, and then 1 times 5 is 5. And so 20 over 5 is equivalent to 8 over 2. And so we could multiply these fractions by any multiple, as long as the denominator and the numerator are multiplied by the same number. So generally, a proportion looks like this. We use different letters, A, B, C, D, because the numbers don't have to be equal. Okay, much like the example that I gave above, 8, 2, 4, and 1. Okay, none of the numbers are equal. They're all different numbers, but the ratio 8 over 2 is equal to the ratio 4 over 1. Okay, so how do we solve the proportions? Okay, because obviously what we're dealing with could be considered an equation. Well, we can do the same thing that we always do when we have an equation with fractions. We multiply by the lowest common denominator. Well, in this case, we don't know what B and D are. And so just to be safe, we have to put a B and D in the lowest common denominator. Okay, this LCD has to be divisible by both variables. So if we wanted to get rid of the fractions, we would have to multiply the left and the right side of the proportion by B and D. Okay. If we simplify this, then on the left, the B's cancel, and we have DA. And then on the right side, the D's cancel, and so we have BC. Okay, so let's see. The next page, the workbook has expressed the same exact thing. The letters have been reversed. We had DA, and the workbook has AD. And then on the opposite side, we have the product B times C. Same thing, the order of multiplication doesn't matter. Okay, so in terms of proportions, what we can do is verify the truthfulness of the proportion by doing what's called cross multiplying across the equal sign. We take the bottom of one side and multiply it by the top of another side, okay, which is sort of an alternate way to get this equation here, AD equals BC. So when you're dealing with a proportion, okay, it's important to check that it is a proportion by confirming that each side, left and right, has only one ratio, one fraction. Okay, what we want is one fraction equal to another fraction. And in that case, we can do, as the workbook states, cross multiply. Okay, so here we are told that 3 divided by x is unknown, is equal to the ratio 5 divided by 4. Well, how do we solve for x? instead of writing the lowest common denominator on both sides, instead of doing this, writing a 4x on both sides, showing that the x's cancel out on the left and the 4's cancel out on the right, we could just simply look at solving the proportion as cross multiplying, and you'll see that we get the same exact thing. Whereas I wrote 4 times 3, if you cross multiply, likewise you could write it 3 times 4. Okay, the bottom of the right times the top of the left, and then the bottom of the left times the top right, which would give us x times 5. Okay, and you'll see that we end up with the same exact equation, 12 equals 5x. At this point, it's one step to solve for x. We just simply divide by 5 on both sides, and in this case we would get 2 and 2/5 equals x. Okay, so to save us a little bit of trouble, okay, we can from now on confirm that we're dealing with a proportion, and then just simply cross multiply bottom times top. So with example 2, that's exactly what we'll do. We confirm that we have one fraction on the left side of the equation and one fraction on the right, and now we proceed in cross multiplying. So we would bring down our equal sign first, and then on one side of the equation write 7 times 13, and on the opposite side 10u. Okay, 7 times 13 is 70 plus 21, 91. And now the last step to get u by itself would be to divide both sides by 10, and we would find that u equals 9.1. B. Alright, this time we have a variable on the bottom, but we do have a single fraction on the left and a single fraction on the right, no other terms. We cross multiply, and so we bring down our equal sign. A bottom times across the equal sign a top. 21 times m is 21m, and then 4 times 3 on the right hand side of the equation. 4 times 3 results in a 12 on the right, and so here we have a one-step equation. Divide both sides by 21, and it turns out that 12 over 21 can be simplified using a 3. Divide the top and the bottom by 3 to get the simplest form of the fraction, which is 4/7. Example 3, sort of a different form of a proportion. It's important to notice that, yeah, we do have two terms on the left, but they are both contained inside the numerator of a fraction. We have a large fraction bar on the left, and so 2v and 8 are all contained within the same fraction. So we look at the left as being one fraction or one ratio. Likewise, on the right, we have 3/4, which itself is 1 ratio. So we have a proportion. This is a ratio equal to another ratio. And just as we have before, we cross multiply. The bottom of one times the top of the other on the other side of the equal sign. 8 times 3. And then we have 4 times the numerator of the left-hand side ratio. And we want to take the 4 and make sure that we multiply the entire numerator. So we place 2 plus v inside of parentheses. Okay, so at this point we've carried out the cross multiplication. We no longer have an equation with fractions. We proceed in the usual fashion, get rid of the parentheses. Okay, combine like terms. On the right, 8 times 3 is a 24. We distribute the 4 on the left. We get 4 times 2 is 8. 4 times v is a plus 4v. The v is only on the left, and so we need to rid the v of the 4 and the 8. And the first step would be to subtract the 8 from each side. 24 minus 8 gives us a 16. And finally, we have we've worked it down to a one-step equation. We divide both sides by 4. The 4's cancel on the left, and we end up with v equals 4. And just as all of the other equations before, we can check our solution by simply taking the original equation or proportion and inserting the number that we suspect is the solution in the place of the variable. We think v is 4, so on the top left side we write 2 plus 4, and then we divide by 8. And we want to check and make sure that these two are equivalent fractions. Well, on the left we get a 6 in the numerator and an 8 in the denominator. And if we simply divide 6 and 8 by 2, we get the ratio on the right side, 3/4. And so our solution of v equals 4 checks out. Example 4. We have multiple instances, 2 instances of the same variable. But all we really need to do is confirm that each side represents only one ratio. And here we have a large fraction bar, and it spans over the top of the w and the plus 6. So this expression is contained within the denominator of one ratio, and then the 10 is the numerator of that ratio. So the entire left-hand side of the equation is one ratio. So no doubt the right-hand side is a ratio. We have one ratio equal to another ratio, and so we cross multiply. We get w times 10, and it doesn't really matter what side you place this product on. 10 times w can go on the left or the right. We could place it on the right. But then the product of the other two denominator numerator pair has to be placed on the opposite side of the equation. We have 5, and then we have the expression w plus 6, and that must be placed inside parentheses. And so here we have our new form of the same equation, except with no fractions. Our first step is to get rid of the parentheses, distributing the 5. We get a 5w plus 5 times 6, 30. This equal sign looks a little like a Z. That's supposed to be equal. We have a W on each side of the equation. We want to combine those terms. So I subtract the 5W from each side. That leaves a 30 on the left, and then 10 minus 5 is 5, W on the right. And to finally get W by itself, we divide by 5. And 30 divided by 5 on the left would give us a 6, and the 5's cancel on the right, leaving the W by itself, and so W equals 6. Doesn't take long to put it in the original fraction and check the answer. For the left hand side, we write 10. The denominator is W, which we'll replace with 6, the solution. And then we add a 6 to that. And the right side of the original equation has a 5 in the numerator, and then we place a 6 in the denominator in the place of the W. So are these two ratios equal? Well, 10 over 6 plus 6 is 10 over 12. And if we divide 10 and 12 by 2, then it reduces 10/12 to the equivalent fraction, 5 over 6. And so these are equivalent ratios. W equals 6. Checks out. For B, here we have a sort of a new occurrence. We have a negative here, but it's actually not such a big issue. What we'll do to prevent any confusion with the negative is to realize that we can place the negative instead of just simply having the negative sitting in front of the fraction. We can take the negative and associate it with the 3, or we could move it to the denominator. But you only want to do one or the other. You don't want to place a negative beside each one. That would be creating another negative, which would change the problem. So what I'll do is I'll just associate the negative with the 3 on the top ratio on the right, and carry down my x. We have a ratio equal to another one. We cross multiply. 12 times x goes to one side of the equal sign, and then a negative 3 times x plus 3 gets placed on the opposite side of the equal sign. We have an equation with no fractions, which is definitely preferable. And at this point we distribute to remove the parentheses, giving us a negative 3x. Negative 3 times 3 is a negative 9. We have x's on the opposite sides of the equation, and I want to combine like terms, so I take this term with the x, I do the opposite and I add it to both sides. 12 plus 3 is 15. X equals negative 3 plus 3 cancels these terms out. I'm left with the negative 9 on the right. And at this point, to get my x by itself, I divide by 15. 15's cancel on the left, and I get a negative 9 over 15 on the right, which can be simplified if I divide numerator and denominator by 3. Giving me a negative 3 over 5, which is in simplest form. So for the next page, we're going to work some word problems that involve equations in the form of proportions. Our first problem reads, a recipe for cookies calls for 2 cups of sugar and will make 24 cookies. If we want to make 66 cookies, how many cups of sugar will we need, assuming that we keep the same proportion of sugar to cookies? Okay, now the important part about proportion word problems is that once you decide on a particular format of your ratio, then you need to stay consistent on the left side and the right side of the equal sign. So it's important that you pay attention to how you build your ratio. So the workbook has decided to place sugar over cookies, and so we'll maintain that relationship on the opposite side of the equation. Sugar on the top, cookies on the bottom. So very important that you stay consistent. So the recipe ratio is found on the left side. We had 2 cups of sugar for 24 cookies, and so we don't know how many cups of sugar that we need, and so the top right is left blank, and then all we know is that we want to make 66 cookies. So cookies, the 24 went on the bottom, so 66 has to go on the bottom. Alright, and so at this point we would fill in the blank with a variable, x. And so x, if we defined it, would represent the number of cups of sugar. Okay, so we have 2 over 24 equals x over 66. So here we have our proportion on the next page. 2 cups of sugar to 24 cookies, but we want to make more cookies. We want 66. So with cookies on the bottom, we switch to the right hand side of our proportion, and we place 66 cookies in the denominator, and then use an x variable in the place of the cups of sugar. Cross multiplying gives us a 24x on one side of the equation and 2 times 66 on the opposite side. 2 times 66 gives us 132, and with a 24x on the right, we divide both sides by 24 to get the x by itself, and x ends up equaling 5.5 cups of sugar. So that makes sense because we wanted to make more cookies, so we had to use more than 2 cups of sugar. So to make 66 cookies, it'll take 5.5 cups of sugar. Example 5 reads, the residents of a city voted on whether to raise property taxes. The ratio of yes to no votes was 7 to 5. So we're calling the order of ratios in the beginning. Yes to no would be written in fraction form as yes over no, and we're given the ratio 7 to 5, and so we would write 7 over 5. Now this isn't our proportion, we're just setting up our first ratio. The problem continues and says, if there were 5,502 yes votes, what was the total number of votes? Okay, so we know the ratio of yes to no is 7 to 5. So what we do is we take our 7 to 5 and we set it equal to another ratio, creating a proportion. And we also look back and check where our yes votes went, how we constructed our ratio, and yes votes went on the top. We had 7 on the top for the yes votes. So the 5,502 for our second ratio should be written on the top. And so what we don't know is how many no votes are associated with the 5,000 yes votes. Okay. So this is going to be sort of a roundabout way of solving the problem, and keep in mind that the question was not how many no votes were there, the question was how many total votes were there. Okay, and the way we're using X, we're using it to represent the number of no votes. So yes on the top, no on the bottom. Cross multiplying, we get 7x equals 5 times 5,500. Okay, well, what is 5 times 5,502? We'll pull up our calculator. 5,502 times 5 gives us 27,510. And with 7x equal to 27,510, we divide both sides by 7. These 7's cancel on the left, leaving x by itself. Bring my calculator back up and divide 27,000 by 7. And that gives us 3,930. And these are no votes. Okay, and the question is, always double check your question, what's the total number of votes? Total votes equals yes plus no. The yes votes were 5,502, and the no votes were 3,930. We add these two numbers together. Somewhere. Let's see. 5,002 plus 3,930, enter, and we get 9,432. And so this is the solution, the answer to our question for example 5. Example 6, a machine produces 55 bolts in 6 minutes. At the same rate, how many bolts would be produced in 4.8 minutes? We decide on the structure of our ratio, and when we create our proportion, the equation, the equality of two ratios, we keep the same relationship of bolts on the top and minutes on the bottom. Now, we're told what the machine produces. It says 55 bolts, so 55 goes on top, and that happens in 6 minutes, so we place 6 minutes on the bottom. And now the question is, how many bolts do we produce for the ratio on the right? We don't know the bolts on the top, but we do know the minutes, so we place 4.8 on the bottom. The question mark becomes a variable, and we can use x as we usually do. And so we have a ratio equal to a ratio, and at this point we can cross multiply. This gives us 4.8 times 55 equal to 6x. .8 times 55 equals 264, and so we have 264 equals 6x, and to solve for x we divide both sides by 6, and 26 divided by 6 would give us 4 with a 2 left over, and then 24 divided by 6 is 4 again. So the 6's cancel on the right, and we end up with x equals 44. So which makes sense. We have less time than 6 minutes. We only have 4.8, so we have less than 55 bolts made, 44. Alright, example 7. Each marble bag sold by Keiko's Marble Company contains 6 purple marbles for every 5 blue marbles. If a bag has 45 blue marbles, how many purple marbles does it contain? Okay, so we have purple and blue. We start out with a given ratio of 6 to 5. So the way I'll set up my ratio is purple in the numerator and blue in the denominator. And for the ratio on the right side of our proportion, we maintain the same format: purple on top, blue on the bottom. Now we place our numbers inside of our proportion. 6 is purple, so it goes on the top. 5 is blue, it goes on the bottom. This is the ratio we were given. And now we have a bag that has 45 blue marbles. And so for the ratio on the right, we have the denominator, 45 blue, and we put blue in the denominator. And so we don't know how many purple marbles we have. So the numerator becomes our variable. And at this point, after setting up the proportion, we can solve the equation by cross multiplying to get 6 times 45 on one side and 5x on the opposite side. 6 times 45, well, if we multiplied 6 times 50, we would get 300, and then if we subtract 30, we get to 70. And to finally get x by itself, we divide by 5. The 5's would cancel. And on the right, we would have x by itself, and 270 divided by 5 would give us 5 and 4, 54. So let's see. If we compare that to the original ratio, the ratio has us having 6 marbles, more marbles than 6 purple marbles, more purple than blue. And that's exactly what we end up with. We have 54 purple marbles and 45 blue ones, more purple than blue. So this makes sense. And again, this is purple marbles. Example 8. A pancake recipe requires 4 1/2 cups of milk to 1 cup of flour. So we've got some fractions thrown in there on top of the ratios that we have to construct. If 2 1/4 cups of milk is used, what quantity of flour will be needed? Okay, so we have milk and we have flour. So what I'll do is I'll set up my proportion with milk on the top, flour on the bottom, and the same for both the left and the right hand side. So with the design of my proportion set up, I'll enter the numbers. So how many cups of milk? Well, 4 1/2, and so we write 4 1/2. That's the cups of milk. So 4 1/2 goes on the top, and then we have 1 cup of flour, and so 1 goes in the denominator where the flour goes. Now, okay, it says if 2 1/4, okay, so 2 and the fraction 1/4 cups of milk is used, then what quantity of flour will be needed? Well, on our right hand side ratio, we don't know the flour. That's the question. So the flour on the right side becomes our variable, and the milk gets replaced by 2 1/4. So here's our proportion: 4 1/2 over 1, 2 1/4 over x. If we cross multiply like so, we have x on the left, one times 2 1/4 just gives us 2 1/4 on the right. And now if we divide by 4 1/2 on both sides, the 4 1/2 on the left cancels, and we simply need to calculate 2 1/4 divided by 4 1/2. Well, you should be familiar with the fractions 1/2 and 1/4. And so another way to write 2, let me clear this out so we can actually see the calculator. Another way to write 2 1/4 is 2.25, and that gets divided by 4 1/2, which can be written in decimal form as 4.5, and we hit enter and we see that we get 0.5, or we could write 1/2. So how much flour will be needed? And we measured our flour in cups. Well, we're making, let's see, we're making less pancakes. So we have 1/2 cup of flour. That we need to use. And it didn't really tell us how many pancakes we were making. I hope it's enough for me. Alright, finally, example 9. A weight of 10 identical samples of a substance is 0.1 pound. What is the weight of 10,000 samples? Well, we have, let's see, how do we want to write this? We'll write it as samples and pounds. So our proportion would be designed with samples on the top, and it doesn't really matter. You could put pounds on the top and samples on the bottom. I'll set mine up this way. And so if our ratio is designed with samples on the top and pounds on the bottom, then we have to maintain that on the right side of our proportion. And our ratio starting out was 10 to 0.1. So we have 10 samples and 0.1 pounds. 0.1 goes on the bottom, 10 on the top. What's the weight of 10,000 samples? Well, 10,000 is associated with the number of samples, and we have samples on the top. So 10,000 needs to go in the numerator. And we don't know the weight, and pound is a unit of weight, and so we place a variable in the denominator on the right side. At this point, we cross multiply, and we get 10x equals, multiplying 10,000 by 0.1 will give us 1,000. Okay, 0.1 is a tenth, so a tenth of 1,000 is the same as 10,000 divided by 10. So we get 1,000. You could check that with your calculator. But at this point, we have 10x equals 1,000. To get the x by itself, we divide by 10. The 10s cancel, and we get x equals 100.